Hello students, in this video we will discuss the important topics for the exam science for grade 6. So let us start. This is a video part 1. So you can see here there are 3 states of matter: solid, liquid and gas. So this video is kind of a summary video. So we will so as you can see, the solid has the particles very close to each other, and in the liquid you can see the particles are away from each other. There are gaps, and in the gas they are farther away. They are very far away from each other. So this is solid, liquid and gas. Solid is kind of a metal like gold, liquid is like water, and gas is like oxygen, nitrogen, etc. And in solid, potential energy is the most. Here the particles are having potential energy greater, and liquid particles gas particles are having the least potential energy, which is very less, minimum. Now, if we talk about kinetic energy is the energy because of the motion, because of the vibration, the particles are moving. So you can see these particles are moving very much. So so the kinetic energy of the particles of the gas is the greatest one, the most one, and kinetic energy of the particles of the solid is the minimum or is the least. It is almost zero. So you can see they are no having space to. And you can see the direction of the arrow. Kinetic energy, when we go from left to right in the direction of the arrow, the kinetic energy is increasing. Like in the solid it is the least, liquid a more, and the gas the most. Now we have particle motion. Particle motions, when we go from left to right, particles motion increases. You can see the arrow pointing towards the right, pointing towards the gas. So the particle motion in solid is the minimum. That's why the kinetic energy is the minimum, because kinetic energy is based on the motion. And then for liquid it is more than solids, and for gas it is the most. When we talk about attractive forces or the bonding forces, the bonding between the particles is the greatest in the solid. That's why they are very close to each other. And like it is similar to the close friends, where close friends are very close to each other. They have very good bonding, they have very good attractive forces, you can say. So this is solid particles are like close friends, family members. There is a good attractive force between the members, which we call bonding of love. So this solid particles are like family members, like close friends. But the gas particles, they are not having any attractive force, almost very little. They are scattered. So they are like the kind of they are fighting each other. They don't have any attraction between them, they don't have any bonding between them. There is bonding, but very little. So you can see they are scattered. Liquid are medium. Liquid particles are medium. They have some attractive forces between the particles. They have some. They are not so bonded. So let's move to the next. Here is the table for the similar, the page which we discussed last page. We have solid particles motion is 0, for liquid some, and for gas the most. Kinetic energy for solid 0, because motion is 0, so kinetic energy is 0. And liquid has some kinetic energy, and the gas has the most kinetic energy. Potential energy in solid is the most. See, where there is a lot of bonding, too much attractive force, the potential energy will be too much, you know. And then liquid has some, and gas has the least. Attractive force between the particles in solid, it is the most. In some, gas, now further to states of matter, you can see here solid, liquid, gas. You can see the particles are connected in solid with the bonds. This line, these lines, you can see the balls are connected, the particles are connected in solid. They are loose, they are not connected. In the gas, they are not connected. Don't worry about plasma right now. For grade 6, we will study this in higher grades. Now, so solid takes heat to change into liquid. When you give solid heat or thermal energy, when you give solid heat or thermal energy, it will change to liquid. And liquid takes heat to change into gas. When you see, you can see the arrow here, you are adding heat and you are getting the states which is in the right side. You add heat to the solid, you get liquid, it becomes liquid. You give heat to liquid, it becomes gas. And you give heat to gas, it becomes plasma. Okay, so example, like you have ice, you heat the ice, that becomes water. You heat the water and it becomes vapor. You see the in the kitchen what happens. You Okay, so this is, you see, add heat. In this whole grade 6 term 1 science book, you can understand thermal energy as heat. If you don't be bothered with don't worry about the words thermal energy simply is heat. So if I say in this video heat, think it as thermal energy. If there is thermal energy in the slide somewhere, think we feel easy, because heat is very common word we use a lot during day to day life. But thermal energy is a little formal which we use in school, and so solid takes heat and becomes liquid, liquid takes heat and becomes gas. Okay, and now opposite also happens. You know what, like when you give gas, or when you take heat from gas, see, gas gives heat to change into liquid. It means if you take heat from the gas, it becomes liquid. When you take heat from liquid, it becomes solid. You see, you see the glasses, the car glasses, window panes, there are a lot of water droplets. That happens because of the taking of heat from the air, or you can say cooling of the air, you get the liquid. And like when you take water and you put it into the fridge, what you do actually, you take the heat away. You take the heat away from the water and it becomes ice. It becomes ice. Okay. So he in these two boxes we are giving the heat. Okay, we are giving the heat, and solid, we are giving the heat to solid, it becomes liquid. We are giving heat to liquid, it becomes gas. So it becomes liquid. We are okay. Now what is random motion? See, random motion is motion in all directions at different speeds. At different speeds. Okay. And in all directions. No regular, no regular, irregular. We call random motion. You know, the gas particles has the similar motion. They collide, they strike, they collide with each other, they strike with each other, and they collide with the walls also, walls of the container, walls of the glass, walls of the, you know, whatever container they are kept in. Particles of all liquids bump and flow past each other in random motion. So not only the gas, but liquid particles also, they bump with each other, they flow past each other, and the motion thing for you, diffusion. What is diffusion? Diffusion is mixing. It is kind of fusion. So you know the fusion of music. In the fusion of music, there are two different instruments played together, in harmony, and that we call fusion. So similarly here, diffusion. What is diffusion? Mixing. Now, diffusion, motion of particles from high concentration to low concentration. So, what happens in diffusion is, like, for example, there is water already in the container. You add some ink, you add some color. That color, after some time, it gets mixed with, with the water, and that process is called diffusion. After some time, you see the whole water is bluish. The whole water color changes into blue, and that is because of diffusion. And the particles diffuse until the concentration is the same in the cup. Diffusion does not stop until it is throughout the container, until it is similar in the container. You can see in this picture what is happening here. So yeah, it is diffusion. See here, the yellow particles and the blue particles are separate. Here they are mixing. They started mixing here, and here they are mixed totally. So this is called diffusion. Now kinetic energy. See, the kinetic means motion energy, kinetic energy, which is motion energy. It is energy due to motion. No motion, no kinetic energy. Or if we say zero motion, kinetic energy zero. More motion, more kinetic energy. More mass, more kinetic energy. So if we compare with a car and with a bike, so more kinetic energy will be for car, because car has more mass. Bike has less kinetic energy because bike has less mass. And if there are two cars, one car is moving at 100 kilometer per hour and the other car is moving at 80 kilometer per hour. So kinetic energy of the car, which is at 100 kilometer per hour, has more. Kinetic energy will be more for more motion. Now motion lines, what are motion lines? So motion lines are used to show particle motion on paper. This is kind of picture. Motion lines is a picture. we use to show the particles motion. More motion lines, faster the motion. If you see more motion lines on the paper, it means the motion is more. What is thermal expansion? See, thermal means heat related. And expansion means increase in size. Expansion, like, some business expansion happens, like, so that expansion, it means increase, bigger, grow. So thermal expansion. So there is expansion in object when you give heat to that object. Okay, like a metal, if you heat a metal, that size will increase. On heating a material, temperature increases, it means strike, and push each other farther apart. Then what happens? Increase in volume, the size, and this is called thermal expansion. You can see here, after heating the water, there is, you can see this is going up, the volume becoming more, and this comes out of the container. What can you conclude about how adding energy to the liquid to the right will affect this? 80 degrees Celsius here, the heat, there is more heat here. So what happens to the particles? Particles start moving faster or slower? Faster. So energy heats up, activates the particles, so the speed increases. See, if we have energy, more energy, we feel that we can jump, we can run, we can, so but without energy, we feel, let's sleep, let's take rest, don't move, huh? This happens with the particles also. When they have energy, when they have heat, when they have thermal energy, they are very active, like we. They are, their speed increases. Okay. Now, thermal contraction. Thermal contraction is opposite to thermal expansion. See, contraction means reduce in size. Size becomes smaller. On cooling, and this happens on cooling. Remember, the expansion was happening because of heating, but this happens, contraction happens on cooling. What happens after cooling? Particles slow down, they collide less with each other and causes to take up less space. What is the result? The result is decrease in the size, and this is called thermal contraction. So this is opposite to thermal expansion. Okay. Now we can relate this as, like when we feel cold in the winter, we are slow down. We feel to, take the blanket and don't move, just, and we don't feel active. Okay, so that's similar with the particles. When they are, cold, when they are cool, they slow down. In this table, there is a comparison difference. So thermal expansion and thermal contraction. Volume, thermal expansion increases in the volume, and in contraction it is decreasing. Heat also increases. Thermal expansion requires heat, and thermal contraction does not require heat, but it requires cooling. Particles motion increases in thermal expansion. In thermal contraction, it decreases, and the space between particles in thermal expansion, of course, becomes more big, and in thermal contraction, it is expansion. The company A has a lot of business expansion, So their shops you will find so many, too many places. But if the business has contraction, you will find the shop only one, or like this. Now thermometer works on thermal expansion and contraction. In the liquid in the thermometer, that is called mercury, when it touches the body part of a human, it heats up and it expands. There is thermal expansion happens. Now when we remove, it cools down and then it contracts. This size of the liquid decreases. And this is the explanation when what I already explained in the last slide. Let's talk about the conductor and insulator. Conductor is, the materials like metal, which pass does not allow heat to pass through, like wood, glass, plastic, metals like iron, copper, gold. See, when you touch this flame of fire with this metal rod, after some time, do you think you will feel the heat here? Yes, because thermal conductor, metal is a conductor and the heat passes easily through the conductor. But if this is of plastic or if it is wood, does it pass through? No. See another slide for conductor and insulator. This is clearly conductor and this is insulator. Insulator as well. The other properties of conductor is it easily gets heated and cold also. Okay, but wood, no. It takes time to get heated and it takes time to cool also, more time. Now kitchenwares, are made of metals as well as some insulator part also are there. See, this is conductor part, which is why we make this as a for the with the conductor, because it heats easily and faster, and then when we don't need it cools faster. And this is insulator, which stops heat to enter into this insulator, and we are safe, we don't feel any burn. Then metal pan, again conductor. On the other hand, the oven safe glass or ceramic, like this is glass. This is metal, not metal. This is metal. This is glass. Insulator. See, this is insulator. This is metal is conductor. Conductor takes less energy to heat up. Insulator takes more energy to heat up. Uh, metal pan metal pan cools faster and this cools slower. Here it is hidden. It cools slower. The specific heat of air is 1 joule per kg Kelvin, and the specific heat of copper is 0.4 joule per kg Kelvin. Which specific heat is less? Of course, for the copper. Okay, so the right statement is copper transfers thermal energy the quickest. Copper is a good conductor. Air is a bad conductor. We can say air is an insulator. The good conductor, the conductor has a specific heat very less. It means that does not need too much heat to be heated. Okay. Quickly, you can heat copper. Now, this is conduction, convection, and radiation. This page is very important, very important. Let us, this is new things: conduction, convection, and radiation. These three is actually heat transfers method. Conduction is a heat transfer, convection is heat transfer, radiation is also heat transfer. So conduction happens in solids, liquids, and gas. Here particles transfer the heat. Convection only in liquids and gas. Radiation, it happens in vacuum or in gas also. The unique thing about radiation is the radiation can take place in the space as well, where there is no particle. We know that the heat from the sun between the earth and the sun, there is empty space, there is vacuum as well, where there is no particles. So imagine how heat comes. So heat comes through radiation. Now, how conduction takes place? So conduction takes place from an object of high temperature to object with low temperature. You can say that heat moves from high temperature area to low temperature area in the conductor, in the particles, in the materials. And convection, how it happens? So hot fluids go up, then cold fluids come down, and it happens again and again. It repeats. Radiation happens in the form of EM waves. See, if we see this picture, you can see this is waves. Waves. EM yani electromagnetic. EM is electromagnetic. So this is electromagnetic waves. The heat transfer in the form of electromagnetic waves are called radiation. Okay, and you see the conduction here, and convection happens like this. See, the bottom liquid heats up and then goes up. Then the cold water comes down. Then it becomes hot. Then it goes up. Then again some cold water comes down. And this way it keeps on heating and heating and heating and start boiling. This is called convection. Okay, so particles are needed in conduction? Yes. In convection? Yes. In radiation? No need. Without particles also, it can happen. Examples of conduction: heating of metal rods, heating of water and air, and the radiation example is heat from the sun to the earth. Radiation transfer of, we will learn in this slide more on radiation. Radiation is transfer of thermal energy from one material to other by electromagnetic waves. Can occur in free space, which is vacuum, without particles, and solids, liquids, and gases as well. More on radiation. Warm objects emit more than cold objects. Everyone gives radiation. We also, human bodies also give radiation. So if you are like warm objects, the hot objects give more radiation than the cold objects. Okay, like hot, thermogram. Now next is thermogram. What is thermogram? Thermogram is an image, a picture that measures the radiation. Thermogram gives us an idea how much radiation is happening. So in thermogram, we can see white color, red, yellow, blue, purple, black. What these colors indicate? So white, red, yellow indicate hot objects. Blue, purple, black indicate cooler objects. They are less radiation giving objects, and these are high radiation giving objects. So those color are white, red, yellow. Why? Which of the following does not represent an increase in thermal energy? So the D is the right answer. The substance changed from a liquid into a solid. So because the increase in thermal energy, this does not represent increase in thermal energy. Here only the state changes. Here what happens, a liquid becomes solid. There is no any other change, so there is no change in thermal energy. But if we see the other three options, you see here the temperature increased by 10 degrees Celsius. It means increase in thermal energy happening here. The volume is increased by 10 milliliter, and it means you are adding more liquid, so it means more thermal energy. And the mass is increased by 10 gram, again more substance, so more thermal energy. Only the D option has nothing change in the substance, in the temperature, in only change in the matter, change in the state. Some students want to demonstrate thermal expansion. They devise the following method. A large black balloon is taken to a shady area and filled with cool air. The balloon is then taken to a bright sunny location. After a short time, the balloon begins to expand. What does this investigation verify? So the answer is the particles gain energy in the heat in the sunlight, and the material takes up more space. The air inside the balloon has expansion. This is a case of thermal expansion, which we discussed in the previous slides. Particles gain energy. The materials takes up more space. The particles are undergoing a change in energy. Which statement best describes what is taking place in the images? The particles in the middle have more kinetic energy than the particles on the right. This is solid particles, and this is liquid particles. So you can see this statement B is the right statement. When solid becomes liquid, we call melting. And when liquid becomes solid, we call freezing. Freezing is also called crystallization. Freezing is also called crystallization. Now condensation. This is we talked about little on this condensation. In the winter, we see some water droplets on the glass. This is condensation. This process is called condensation. This is simple, nothing but change of gas into liquid. See, gas can change into liquid. I repeat, gas can change into liquid. Example, vapor change into water, and gas gives heat or cools down and becomes liquid. How it happens? When you cool the gas or when you take the heat away from the gas, then only condensation takes place. Now crystallization is the opposite of condensation. In condensation, we get not, sorry, not opposite, but it is different. So crystallization is becoming a crystal, becoming a solid from liquid. From liquid, it becomes solid. That is called crystallization. Because why the name is crystallization? Because it is crystal. We get crystal from crystallization. Liquid gives heat or cools down to become solid. So how liquid becomes solid? It cools down, or you take the heat from the liquid away, then it becomes solid. How do clouds or fog form? So clouds are formed after condensation and crystallization. In the clouds, you see there is not only the droplets, water droplets, but some ice crystals also, small ice crystals. Clouds are made from thousands of droplets and ice crystals. I repeat, we learned what is condensation. Condensation is becoming liquid from gas, and crystallization becoming solid from liquid. And thank you for watching the first part of the video. Thank you very much.